Today's video I would like to introduce a very nice problem. It's coming from Pittsburgh 1996. Here is the following setup. Our goal, we are going to find all n as a positive integer satisfy this statement. So we get 3 to the n minus number 1 plus 5 to the n minus number 1 divides 3 to the n plus 5 to the n. In the other word, this term, which is 3 to the n plus 5 to the n, is divisible by 3 to the n minus number 1 plus 5 to the n minus number 1. Okay? Before we get started, I would like to remind you about the divisibility definition. So we are saying n divides b minus a. So an equivalent b minus a equals n is multiplied by k, where is k is a some integer. Okay? If you or b minus a over n is an integer. Okay? This one implies b minus a must be super equal to n, because if you would like to apply the modular arithmetic on this one equivalent b minus a equals n k, which is equivalent b minus a is a congruent to 0 mod n. In this case, n is a divisor of this one. Okay, or n is a multiple of b minus a. Okay, if I'm going to move over this a to the right, so I'm simply getting b equal b is a congruent to a mod n. Now let's get rid of this one and go ahead to our problem. So we say in this term divides this term. We say in 3 to the n minus 1 plus 5 to the n minus 1 divides 3 to the n plus 5 to the n. I'm going to use a nice trick here. So 3 to the n minus 1 plus 5 to the n minus number 1. If you pick up a nice observation here, so this term, the same term, is going to divide 5 times the same term. 3 to the n minus number 1 plus 5 to the n minus 1. Okay, it's more simple. Since we get this one divides this one, I'm going to add or subtract the same term, minus 3 to the n plus 5 to the n. So we get 5 is multiplied by 3 to the n minus number 1 plus 5 to the n minus number 1. Notice here we are working on this one only. If what I'm going to do here, I'm going to distribute this 5 with this one. So I will have 5 to the n is okay. I'm going to split this one into two terms, which becomes 2 times is multiplied by 3 to the n minus number 1 plus 3 times is multiplied by 3 to the n minus number 1. Okay? So this one is going to be 2 is multiplied by 3 to the n minus number 1 is not going to be changed, but this one becomes 3 to the n after you distribute this one with this one. So I get 3 to the n plus 5 to the n. So what to do here, then after you consider these two terms, let's put it here. I got minus 3 to the n plus 5 to the n. Then we get this one cancelled out with this one cancelled out with this one. Now we will see the trick why you put this one on this form. Now these terms show up here. We need to cancel them out. I will be left only with this one, which is 2 is multiplied by 3 to the n minus number 1. Okay? So this, the whole thing here becomes 2 is multiplied by 3 to the n minus number 1. According to the divisibility statement which we saw in previous board, we get this is numerator divides denominator. Always we get numerator is bigger or equal denominator. So we get this one divides this one, which means always this one is a smaller or equal to this one. For all n is super equal to 1, we get 3 to the n minus number 1 plus 5 to the n minus number 1 is inferior or equal to 2 is multiplied by 3 to the n minus number 1, according to the divisibility property. So let's split this one into two terms. So I get 3 to the n minus number 1 plus 3 to the n minus number 1. So we are going to cancel out. Since we get one of the 3 to the n minus number 1 in each side, we are going to cancel out that. So I will be left with 5 to the n minus number 1, which is inferior or equal to 3 to the n minus number 1. So we get two different primes with the same exponent, but this is not true, because we get 5 is smaller than 3 if you have n above number 1. Okay, the only thing to make this statement true, we will have the exponent 0. If you get the exponent 0, you get number 1 here, I get number 1, which is true. So the only way to get this one true, which means n must be equals 1, is a solution for this equation. Okay, so thank you for watching. I will see you in next video. Bye.